And so you know how you're building this thing, you know how many files you're going to lay down on it, so you can actually choose that parameter region. Mount it up, yeah, so create a file system, mount it up, and you just tar all your files into it. And that basically is everything except user, plus the odd little bits of user that you actually need. The way I actually do this is I move the user out of the way, tar the whole thing up, and then surround the 20 odd files that have a /user that I need. So then what have we got to do? We run dev-fs-adm to populate the device tree, because when this thing boots, it's going to want a device tree for all its drivers. Something that I didn't do for a few months. Delete all the disk devices that it's created, because it will actually populate that from the system that you run the build on. So it was wonderful. I saw it was coming up with like CD at some reasonably high sort of controller number. That's because it's already taken the first view. We created a .cd-rom. That's where we're going to mount the ISO image when we're done. We copy this .volset ID file into place. Touch a few things. I copy the SMF repository into place. You could build it from scratch, but then you'd have to do manifest import at first boot, and that would be a pain. So you do it once, save it off, and then you drop it back in next time. For Tribblix, I actually do that on the regular CD as well. If you ever installed OpenSolaris or OpenIndiana or Solaris 11, and at first boot it does this sort of manifest import. It imports about 200 manifests. If you're running inside VirtualBox, it takes forever. It's funny, but the result of that operation is going to be exactly the same for every single person who installs this operating system. So I run it through once, save off the result, shove it back in, and then ship what comes back. Unmount it, then just gzip it, so that on the ISO it's actually gzipped, and Grub will uncompress it as it pulls it off the disk and shove it into memory. Creating the Solaris.zlib, it's just an ISO image. You just look at ISOFS, call it Solaris.zlib on user. And that's how you compress a file using Lofi. You just basically point Lofi-adm at it and say, -C, choose your compression scheme. In our case, use it. So we've got all this stuff ready. And we create the ISO. And the first thing I do is just move all the other junk off to one side. All you need is the files that I showed you earlier. So nothing else matters. So you just move all the rest of it out of the way. Look at ISOFS. Boot from this. That's the boot catalog, which is the other file that I haven't talked about. You set that so that it's got a unique identifier, all these sorts of junk that I don't understand at all. But yes, sort of, everybody who makes Solaris ISOs uses exactly these commands. You give it a name and tell it where to look. There's just one little gotcha, which is that the live CD works ever so subtly differently from a normal boot. For instance, you get /user from Solaris.zlib. There's this prompt for keyboard, there's a prompt for language that occur in the middle of the boot sequence. It might have an installer on it. All this is there's just a special SMF service with a sort of a live media method that gets inserted into the middle of the boot sequence. And that actually disables various other things that would normally happen. So it mounts it. The file system's the way it knows, but it disables the normal mounts because there is another operating system there to mount up. It doesn't actually do anything terribly complicated. The only thing to remember is that once you've installed this thing, you just remove this service and everything will happen as normal. That's the plan. Okay, so I mentioned installation. How basically do you install? You know, you booted this thing, you're in this live mode, you want to install it to something. Well, assuming we're using ZFS, we've got some disks, we create a pool, we lay out some data sets, we mount our new root somewhere, and essentially all that happens is that you take what you booted and you copy it onto the destination. And that's all that happens. When you install OpenSolaris or Solaris or any of these, that's really all that's happening. It's taking what it was booted with and copying it across. And then it removes this magic package that sort of knows that it's a live CD and does all sorts of funky stuff. You set some properties, you configure grub so that it knows where to boot from. That's it, basically. In terms of customizations, as I say, you take what you booted, you copy it. If you want to have a different installed system, then you have to have a different boot, a different ISO image to start with. That's why Solaris and most of the other open source distributions have got the live image, the text installer image, the AI image, because they actually want to work in different ways. Now, I couldn't be bothered with that. So, I always start with, so basically I'm booting with the text installer in the other distributions, but I put a lot of other packages on this thing, and you can install any selection of them you like at install time. And that's what that packages directory is. That doesn't work for IPS. The way that IPS is laid out on disk is, you could do it, but you'd be here till Christmas. The way it actually accesses files when installing stuff isn't amenable to being laid out on an ISO, especially a physical ISO, it's not a logical one. If you do ZFS, then basically you have to, in your pool, you basically have to tell it which data set is the bootable one. Because there could be an awful lot, and you could call them anything you like. And normally you'll see this RPOL, root, distribution name, convention being used, and it's normally called RPOL. I say that's just convention. Something else I found was that you actually have to put this property here on your root file system. And because if you don't, when you create a zone, you've got to destroy it. The reason is that there's this UUID, which is set on the root file system. That's inherited by any zone data sets. When you upgrade with something like DEADM, it replaces it with a different UUID, and therefore sort of it uses this UUID to match up any data sets belonging to zones with the boot environment that they belong to. If he doesn't find it, it just gives up. refuses to play. Something else that is familiar to anybody who's used, this is true in sort of ZFS for Solaris 10 as well. There's this thing called boot sign, and this is basically little markers laid down into Grub, so the Grub knows where to start looking. So this is, ties it all together so that Grub basically boots the correct file system, and so that you can do things like just tell Grub, go find my operating system for me. You know, find the root file system is for. This is my boot file system, and then it will Grub will actually populate the boot arguments automatically for you. That's what this .ZFS bootfs is. It's a relatively complicated string, but basically it's all the important things that it's found out by sort of finding the root file system. That's ZF. Well, actually, this is generic. That's ZFS. You could, if you were feeling really sort of retro or primitive, you can install on an alternative file system, UFS, for example. Why would you want to do this? Well, actually, there is a reason why you want to do this, which is that if you're running on really, really memory-constrained systems, which means, well, anything less than a gigabyte in practice these days, although actually it's not like running about 400 meg without too much difficulty on ZFS, you might actually want to run on UFS. But it was an interesting exercise, you know, sort of how do you make it work? So it's the same thing, you know, sort of, instead of creating a pool, you have to go to format, lay out your partitions, NoFS one of them, mount it on /A, then just copy stuff like before. You need to stick it in VFS tab because otherwise it'll boot up, and even if you told the thing to boot from this place, it still goes and looks in VFS tab to make sure once it's found it, even though it couldn't have found it without knowing what its root file system was. You don't have this thing like bootfs and the like, boot arguments that you get from Grub sort of finding your pool. All you've got to do is basically, this is basically EEPROM. So just tell it what the boot path is. It'll save that in what is essentially the EEPROM emulator on x86. And off it goes. Works flawlessly. Zones don't work. It looks for this UUID that I mentioned. Yes, you can see just how well that's going to work. There's no real reason why you couldn't get zones to work. But presumably, if you were putting this thing on UFS in the first place, you were wanting to do something slightly non-static. Something we've been playing with recently is sort of NFS work. I used to use this in production years and years ago. Well, actually, production, your workstations. Yeah, so the workstation files, SparkStation ELC is diskless. Worked great. It's fantastic. All the code is still there. It turns out it still works the same way as it did 20 years ago. And this is x86 at the start. So, you know, it's just like booting off the network. You boot off the network, exe grub, load the kernel, load the boot archive. You can actually load a minimalist boot archive here because it's going to mount the real root file system in a bit. And there is this sort of little shim of NFS support deeply embedded in the kernel, sort of. Trying to work out whether sort of NFS4 is ever going to work, because it says you look at the code and it says no, and hard codes into NFS v3. Basically, you just tell it where it's a boot argument. You just tell it where boot lives. The kernel reads this. Oh right, that's boundless. Right. I say then.